Okay, so this is lecture 2. We're going to talk about ethical dilemmas, how to make choices for ethical dilemmas, which is really hard. And then we're going to talk about codes of ethics, and in particular we'll critique some codes of ethics. So my tone to be set will not be, hey, IEEE has this code of ethics, we all have to follow this code of ethics. It'll be more so, well, they've got some really good ideas here, but we could reconsider some things and think on our own and decide what is right and wrong. So, in resolving moral dilemmas, I'm going to have two approaches. First one will be this approach, a systematic 4-step approach, where the first step will be to gain moral clarity, which usually involves several things. For instance, you need to know that something's wrong. Sometimes that's quite a problem. Someone, sees something and they say, "So what?" Okay, so you got to know what's right or wrong and when you have to do something. And it's important not to ignore problems. I think more ethical issues are like that than we would care to admit. And then you have to have a clarity of what's right and wrong in terms of loyalty to your employer. We do owe some loyalty to our employers, to some extent, at least. And we will be discussing employer loyalty later in class. It's actually quite a tricky issue these days. And then there will be very clear responsibilities to the public. Okay, using the standard, you remember the ABET statement from the last lecture? It said, hold paramount safety, health, and welfare of the public. Connected very closely to that issue of protecting the public is protecting the environment, because the environment, of course, affects the public. It not only affects the public, but it affects animals, plants, etc. Okay, that may or may not affect the public. Right? And there's a lot of complex relations to them. So the first issue is having a clear view of what is right and wrong. In engineering, a lot of the time it will be clear whether someone is something's right or wrong. It will often be the case that you'll be able to see what that is. Sometimes there'll be a sort of a distinction about things being unethical or ethical versus just unprofessional. Okay, and I just lost the screen. Okay, that's probably going to be happening all hour. Next, know the facts. If you're going to make a decision, you have to figure out what the real data are in this problem. In particular, you want to get hard documented facts and discuss them with others. Your competence will matter in gathering those technical facts. That's the first point at which ethics sort of interacts with competence. That's how ethics and professionalism relate to each other. And then you consider options. There's all kinds of options to take. And you'll evaluate and discuss. We'll be doing that in class on quite a few case studies. We'll lay out a case study, we'll discuss it, and then we'll decide this person ought to do this or this person ought to do this. You have to, in those discussions, sometimes take a long-term perspective, sometimes a short-term perspective, and sometimes there is what's called the creative middle solution. Sometimes the solutions you come up with are one of two extremes, and sometimes there's something in the middle that may make sense and be what's called a reasonable decision. You weigh all the factors, you recognize gray areas of compromise, and you make a choice. In a lot of ways, this ethical analysis for a dilemma is a lot like an engineering design problem. You're trying to do the best thing, you're trying to adjust parameters, etc. It sort of feels like an engineering design problem, and I think engineers are generally very good at taking on problems like this. Okay, let's do an example. So here's a case. I'm going to be doing these all semester from the National Society of Professional Engineers, BER, as Board of Ethical Review, and then that's the case number. So engineer A is employed by a software company and is involved in the design of specialized software in connection with the operations of facilities affecting the public health and safety. For instance, that is nuclear air quality control, water quality control. As the part of the design of a particular software system, engineer A conducts extensive testing, and although the tests demonstrate that the software is safe to use under existing standards, engineer A is aware of a new draft of standards that are about to be released by a standard-setting organization, standards which the newly designed software may not meet. Testing is extremely costly, and the company's clients are eager to begin to move forward. The software company is eager to satisfy its clients, protect the software company's finances, and protect existing jobs. But at the same time, the management of the software company wants to be sure that the software is safe to use. A series of tests proposed by engineer A will likely result in the decision whether to move forward with the use of the software. The tests are costly and will delay the use of software by at least 6 months, which will put the company at a competitive disadvantage and cost the company a significant amount of money. Also, delaying implementation will mean the State Public Service Commission utility rates will rise significantly during this time. So that's not good for the public. The company requests engineer A's recommendation concerning the need for the additional software testing. So the question is should engineer A design the software to meet the new standards or not? Should the test be conducted? Okay. This can be a difficult issue. I'm going to pick it apart, view those 4 steps. So, first one, question is what's wrong? What's the core issue or question? Well, will the software meet the new standards? Okay, and of course the standards, well, where do they come from? Well, usually standards are written because there's failure modes in software that come up, cause a problem, pollute or hurt people, cause health problems, cause unsafe conditions in a nuclear power plant, whatever. And so they want to have new standards for the software to avoid those problems, okay? Now the new tests are designed, that engineer A is considering, they're designed to test these new failure modes. So what's the engineer's role in these new standards? Sometimes engineers are the ones that help write the standards. They get put on committees, etc. Okay, or more commonly, in a country this large, what they're going to do is the engineers are going to follow the creation of new standards. They're going to know what's coming up next. That's what's going on in this case. The engineers meeting the old standards, no problem in the test. The problem is new standards are coming soon, and the question is, do we try to meet the new standards? No. Because there could be problems. Known problems have existed for other similar software. Next, you have to know the facts. First of all, it's critical software. We already stated that. It affects the health and safety of the public, not to mention the environment. The new standards to test for new failure modes, and you'd have to understand what those failure modes are. The testing is costly. This is very standard in this sort of system. These are like huge software systems that interface to very complex systems in the environment, such as a large water distribution system or a nuclear power plant and so forth. So testing is very expensive. So the company finances are at stake. You don't want to put your company out of business. You want to protect existing jobs. These are the people that are working right there with you. Okay, you want to do that. The testing will delay the release by greater than 6 months, they said. It will hurt the competitive advantage. That may not be clear. You may be concerned about that in the statement of the case, but another company that you compete with may be dealing with the same issue. If they take the risky approach and do nothing, then maybe they'll be able to beat you right now, but maybe they would end up with a failure and be hurt in the long run. Okay? And then, of course, we said that the utility rates will rise. Now, third step was consider options. Well, option one would just be to ignore the new tests. They're not out yet anyway, the new standards. I don't have to do testing for this stuff. I'm going to go the minimal compliance route and just take care of what needs to be taken care of within the next few months. Leave it at that. All right, so you are taking a risk then for public safety and welfare in order to save time and money. And that'll be a classic trade-off that we look at in this class. Option two would be to conduct the test, risk the jobs, hurt the finances, and become certain that the software will work and protect the safety and welfare of the public. So options 1 and 2 are sort of the two obvious options to consider. Do nothing is the first option. Do everything is the second option. So the question I would ask is whether there isn't the creative middle solution between these two. And this might be possible for a good, competent engineer or engineering team. So the creative middle of the road solution might be, is there a limited version of the full test that can be conducted that would partially test meeting these standards, try to protect the safety, health, and welfare of the public to the greatest extent possible, but at the same time, not spend so much money right now, okay? This might be the best solution. The problem is that you could be criticized from both perspectives, right? You say you're spending money. The group of people that are for option one could say, yeah, but you're spending all this money anyway. It might be half of what you would spend for option two, but the option two people say, well, that's not sufficient. So it can be very difficult, and sometimes it can be political, a choice like this. Next, you make a reasonable decision. Pick option two, since the safety, health, and welfare of the public is paramount by the engineer. This puts you in a very uncomfortable position as an engineer, and another classical thing happens. You as an engineer get stuck trying to do the right thing, and business people, either lawyers or just like MBAs, business types of some sort, are overriding you sometimes in your decision making and saying, no, we're doing this to save money. And there's this battle between sort of the engineers and management, non-engineering management is classic. It happens in many engineering firms, and I've had friends when I was in the industry that were very frustrated by this situation because they would always be sort of upset that they didn't feel that the engineers really had power. It was the business people that had power for determining things with respect to the important technical decisions that would impact people. Okay. If the company says no, we're not going to do option two because it's too expensive, then you have a backup option of option three and try to press for a limited test for the failure mode. So you being competent can put forward this option to the business types, they may accept it. So you have to think that way of trying to get as much as you can in terms of safeguarding the safety and health and welfare of the public. Next approach. That was a 4-step approach, okay? And if you want to review those steps, the slides are on the web. This is a different approach. One that, I'm using 2 textbooks for the lectures today, for the whole semester. Those are the ones by Martin and Schinzinger, the one that's the textbook for this course. And then the second textbook, I take some ideas out of it, and this is one of them. This is the textbook by Harris et al. It's got like 5 authors on it. And I really like this second approach to trying to resolve a moral dilemma. So let's talk about this approach. What they do is they try to make moral dilemmas more analytical or quantitative. So first of all, given a moral dilemma, you establish the key features and issues, and you establish the extremes of the features and issues and paradigms, indicating like on one side completely ethical and on the other side completely unethical. And then we're going to construct a line drawing. We'll show an example below. And you'll evaluate a test case, which is your current moral situation. So let's talk about an example. That's the best way to illustrate this. So this is a bribery example. Victor is an engineer at a large construction firm. He has been assigned the task of being the sole person to recommend rivets for the construction of a large apartment building. After some research and testing, he decides to recommend Acme rivets for the job, which he determines are of the lowest cost and highest quality. On the day after Victor's decision was made, an Acme representative visits him and gives him a voucher for an all-expense-paid trip to the annual Acme Technical Forum, which meets in Jamaica. The trip will have considerable educational value, but will also provide day trips to the beach and other points of interest. Question: if Victor accepts, has he been bribed? It's kind of it's kind of, in a certain sense, somebody can look at it and say, well, no, he made his decision beforehand. They gave him the trip to Jamaica afterwards. There's no bribery here. I'm hearing a somebody that said, talk to me. Yes?
He wasn't bribed, but it has the appearance to an outside observer that he's bribed.
Exactly, and that's a huge problem. If it looks like you're bribed, I mean, in a certain sense, for all intents and purposes, you were, right? Because it looks really bad. And we call into question your professionalism. Person in the back, yes?
In future decision analyses, if he has to come across the Acme company again, it could give the appearance of favoritism.
Yeah.
Previous bribe.
Yeah. And so it can create future problems for him too. It's sort of for Victor, it's sort of like, oh man, why'd you offer me that? You know, it puts him in a really uncomfortable position. On the other hand, hey, go to Jamaica and have a great time, right? He's just there for educational purposes. I mean, my goodness, what's wrong with that? It didn't have any decision. He'd already made the decision. Okay. So let's do a survey. Nobody's filming you. You're supposed to be completely honest. How many people would take would take this offer to go to Jamaica? Okay, so I'm seeing a little over a third. And how many people would not? Okay, kind of split right down the middle. And how many people don't know? Okay, it's complicated, isn't it? Okay, so let's look at how Harris thinks we ought to consider this case. He does the following. He wants us to draw a table. And on this table, he wants you to take the features of the problem, put it in a column on the left-hand side, and then label those features as being large, for instance, gift size large, small, okay? Timing, before decision, after decision, personal gain for a reason, educational gain on the right-hand side, responsibility for the individual making decisions. This is Victor, okay? Sole responsibility versus no responsibility. The product quality for the thing that we're talking about is the worst or the best. Product cost, highest, lowest. Now, yes?
The previous slide said it was the lowest cost.
The previous slide lowest cost and highest quality. The X is in the wrong position. I should have been more careful in putting this down. Thank you. So this X goes here. Okay? Now, the X's are for the test case. That's for Victor's particular case. The table's generic for any kind of bribe, or many kinds of bribe situations. And we look at the test case, and we look at the gift size, and the size is towards the large side. I mean, a trip to Jamaica is expensive. They didn't say how long and what kind of hotel they're staying in, but generally it's expensive. Before decision, after decision, it's not totally to the right. The reason is that, the case didn't go into the details, but he said he made the decision, but was it put in writing? It wasn't very official. And so it's not so clear, so move that over a little bit. And then the reason for taking this gift could be for personal gain or for educational Well, we have to believe him that there's some educational gain to this thing. This is almost all his Victor's responsibility. Product quality is the best. Cost is, move this X over to here, lowest. Okay? And the idea that Harris has is that not only do you write those down, is if you take your action, you underline it if it's a crucial issue, whose responsibility, or the timing maybe. And then he sort of asked the question if this helps you sort of see a creative middle solution. Okay? Now, as was pointed out in the back, you might also worry about effective future decisions. We haven't brought this up yet, but the question is, what is company policy? Yes, there's a, yes. Yeah. Is there appearance of bribery? We talked about that. So it may not be a bribe, but it still may not be a good idea is the thing. Can someone see, Victor's in a tough situation in a certain sense. In a sense, he's not. He can just reject the gift offer, and then he's clean. Everything's clean. But, he hasn't been on vacation for 5 years. He feels he deserves this. He wants to go to Jamaica. So anyway, he can go to Jamaica completely on the up and up. Yes?
Maybe you could give the voucher to like an employee of him that's not responsible for these kind of decisions, and then the employee can take notes on the technical side so that he still gets the education, but he's not getting the trip part out of it, so it doesn't look like a bribe.
Could be, yes.
Something similar to that, where he just goes and only goes for the educational part.
What other ways? Yes.
Talk to his supervisor about it.
Yeah, talk to your supervisor about it. Make it fully open that this has happened. And no secrets whatsoever. I mean, write it down even. I've been offered this, just ask them. I mean, if it's completely open, if this is completely open within the organization, you were given this, is it bribe then? Seems like its tendency towards being a bribery goes way down, right? Because if everybody knows about it and knows, well, he made the right choice on the product, he kept the interest of the company in mind, he didn't have a conflict of interest in making the choice between two companies, one that gives him a trip to Jamaica and one that doesn't, for instance. He might be able to be clean and just tell everyone, and if the boss says, no, you can't go, okay, can't go. I mean, it might be, sometimes just being open and honest like that can get you what you want, and you can do the right thing. Okay, next, codes of ethics. So why are the codes important? Well, to serve and protect the public, to provide guidance and support for engineers. They do provide some inspiration or deterrence or discipline. Sometimes you can say to someone, if your boss is saying do this, you could say, well, the IEEE Code of Ethics, of which I'm a member, says no, you don't do this, then you might help put you on a firmer ground. It also sets these shared standards and does some education, mutual understanding, affects the profession's image. Sometimes there's a limitation of the codes, though. They're really too vague to be useful in everyday ethical decision making. If you run into the first ethical problem you run into, which you've probably already run into if you've been in engineering industry, if you go and open the IEEE Code of Ethics, it's highly unlikely it's going to be useful to you. Okay. And one of the other problems is it's impossible to cover all eventualities in any code of ethics. No, the first code of ethics that we're sort of governed by is the National Society of Professional Engineers Code of Ethics, NSPE. Their preamble is interesting. I'm going to read it to you here. Engineering is an important and learned profession. As members of this profession, engineers are expected to exhibit the highest standards of honesty and integrity. Engineering has a direct and vital impact on the quality of life for all people. Accordingly, the service provided by engineers require honesty, impartiality, fairness, and equity, and must be dedicated to the protection of public health, safety, and welfare. Engineers must perform under a standard of professional behavior that it requires adherence to the highest principles of ethical conduct. All right, and then they go on, have their fundamental canons in their code of ethics is hold paramount the safety, health, and welfare of the public, perform services only in your area of competence. That number 2 is a tricky one, because when you're starting as an engineer, as you people are, well, you go out into a company and they may ask you to do something, you're like, I don't know anything about that. And if you just say that and then don't do the job, you've got a big problem. You're not going to make it very far in that company. So there's a lot of engineers that take on things outside their areas of competence, right? When you're doing that, though, you have to do what? You have to make yourself competent as quick as possible so that you don't screw up and hurt people. Issue public statements only in an objective and truthful manner. We'll be coming back to that issue when we talk about whistleblowing. Act for each employer or client as a faithful agent or trustee. Avoid deceptive acts, of course, like, you know, if you have your specifications, let's say on some, you know, mechanical mechanism or circuit or whatever it is, it's got to be truthful what that circuit can perform like or what that mechanism can perform like. Conduct themselves honorably, responsibly, ethically, and lawfully so as to enhance the honor, reputation, usefulness of the profession. Well, they also have quite a bit more to their code. It's a rather long code. It's in your book. They have rules of practice and professional obligations. Okay, what we're going to do is consider a shorter code in just a minute. This issue of hold paramount safety, health, and welfare of the public, some people have called into question how exactly you assess the impact on the safety, health, and welfare. There's this economist / philosopher, Amartya Sen, uses something called a capabilities approach. He says that, you know, you're doing good in welfare. Your welfare is good if you're able to live a long life in health. You're able to get an education, you're able to work, you're able to have freedom of expression and association and several others. So that would be one way to define welfare. And then he defines a lack of welfare as what he calls capability deprivation. So it doesn't say the engineer should be encouraged to focus on extreme care capability deprivation, and maybe it should. In other words, the question up here in that blue statement, and we're going to come, that's the fundamental dictate to an engineer in terms of ethics. It's that statement. If you say you will learn, you know, one ethical dictate in this class, it's the top blue one. It's that, you know, you want to know that you hold paramount the safety, health, and welfare of the public. The question is whether you believe that's the right thing for us to do. Personally, I have some doubts about it. For instance, should we hold paramount the safety, health, and welfare of all the public? Or should we do all the public and the people that are most deprived in the world, you know, the billion that are living under $1 a day, do they deserve engineering solutions? And do they deserve them with a sense of greater urgency than people that are making, you know, $60K a year or $80K a year or $150K a year or $250K a year? And what does the engineering profession serve? What is the public is the question. Okay? Is it just one segment of the public, or is it really all the public? So, the IEEE Code of Ethics. Now, this IEEE Code of Ethics is sort of interesting. We're going to read over parts of it. We, the members of the IEEE, in recognition of the importance of our technology in affecting the quality of life throughout the world and accepting personal obligations to our profession, its members, and the communities we serve, do hereby commit ourselves to the highest ethical and professional conduct and agree, blah, blah, blah. You know, that's they have 10 statements they want us to follow. Okay? So first one is to accept responsibility for making engineering decisions consistent with the safety, health, and welfare of the public, and to disclose promptly factors that might endanger the public or the environment. Now, I think some people have criticized the way they've said this. Some people feel their statement is not as strong as the NSPE statement of holding paramount, using the word paramount. Here they just say that it's consistent with the safety, health, and welfare of the public. It's not so clear, See, holding paramount means that if your company is requiring you to create a product that's going to hurt the public or hurt the environment, your responsibility is to the public and the environment, not your company. Now, it's not so clear that that statement's coming out of here. It's fuzzy. It's weaker. Okay? 2, to avoid real or perceived conflicts of interest whenever possible and disclose them to affected parties when they do exist. A classic case is if you let's say you work for some company as an engineer and you're looking to buy some parts, and the supplier, you own part of that company, and you buy parts of the company that you part own, and that gives you profit. That's conflict of interest. Okay, those types of conflicts of interest is something we'll discuss a number of times via cases throughout this class. To be honest and realistic in stating claims or estimates based on available data. I tell you, this is one that's pretty surprising. I don't know if you've ever bought electrical components before and trying to design something, but I have, in particular with my students, my grad students and undergrad students. For instance, I buy a motor, and the motor says on its specs that it's supposed to be able to, deliver certain performance. And you get it in, and it's like way below that performance. And the engineers knew they couldn't do that. So there was somebody lied, and it caused a real big problem for us in the lab. We couldn't end up implementing our experiment. To reject bribery in all its forms. I won't read the cartoon, but this bribery thing is complex. I once finished lecturing this lecture, walked out onto the oval, and a young man followed me back to Dries, and he said to me, "Are you serious about this bribery thing?" I was like, "What do you mean?" He's like, "Yeah, I'm serious." He said, "You can't do business in engineering without bribery daily almost in my country." Okay, and that means you people are going to be running into this stuff too, not just in the U.S., but as you work internationally, as many of you will do, you're going to have some very difficult decisions about, what to do. When in Rome, do you do as the Romans, as they say? What do you do? We're going to be talking about that later in class too. To improve the understanding of technology, its appropriate application, and potential consequences. In a sense, this is saying, publish your work, and of course, we already know that you can't, we mentioned this last class period, you can't say everything about what your company's doing. You have proprietary information. Your company has a right to privacy, okay, on quite a few things. And you become part of your company, so you can't just publicize what they're doing. In other respects, in some professions, you can do this. In my profession, it's required that I help improve the understanding of technology. 6, maintain and improve our technical competence and to undertake technological tasks for others only if qualified by training or experience or after full disclosure of pertinent limitations. So it's nice, compared to NSPE statement, they add that last statement. So the boss asks you to do something, you just say, well, I don't know how to do that, but I'm willing to try, and I'm going to figure it out. You be positive like that. You don't just say, I don't know how to do that. No, you say, well, I really don't know how to do that, but I've already started looking into this and learning this, and do you have any other suggestions on what I could learn in order to be able to do a good job on this task? That's how you move into a new area. You're going to be moving into new areas your whole life. Technology is going to change fast, especially electrical technology has changed fast over the last, 30 years or more, right? To seek, accept, and offer honest criticism of technical work, to acknowledge and correct errors, and to credit properly the contributions of others. This is an important issue, basic issue in honesty. You want to get others' inputs into your work to try to improve it. You don't want to get emotional attachment to your work, so if someone criticizes it, you take it personally. You want to incorporate their ideas and then give them credit where credit is due. And don't think this stuff, people taking credit for other people's credit doesn't happen, for others' work doesn't happen in engineering. It does. I had a friend who had this happen to him in an engineering workplace where someone took, claimed they did everything the other guy did for a whole year. This kind of stuff does happen, unfortunately. To treat fairly all persons regardless of such factors as race, religion, gender, disability, age, or national origin. Okay? Now, these are important statements, and you all know that even today, we come from a diverse background, diverse university. You go out in the engineering industry, you'll see discrimination, okay? And it's all rather unfortunate, but it is certainly happening. I'm going to be asking for cases of discrimination that you have seen later in class, and then we'll discuss them in class. Just want to say now that each one of those cases happens in engineering. At least I've heard of them. Avoid injuring others, of course, their property, reputation, or employment by false or malicious action. Pretty clear cases. 10, to assist colleagues and coworkers in their professional development. That means in education. And to support them in following this code of ethics. So for instance, if you're a manager, can you give your employees time off to go take a class at a local university or go to a conference to learn more about a technical area? We have to be worried about that professional development. You don't want to just, Google's fantastic, or Bing, or whatever you want to use, to learn off the web. The web is a fantastic resource. However, there's a lot to be said for classes or for a conference where you go network with colleagues. You can learn an awful lot that way that you're not going to learn on the internet. Okay? And companies should be supporting that. So let's critique the code. You have the moral autonomy. Don't take it as given, challenge it. So some of the problems, like we talked about paramount versus consistent, it's short. It leaves out the possibility of much education or guidance by reading it. Are there many omissions? I think there's at least one. If you consider our earlier definitions of professionalism from the last class period, remember the ASCE, in the spirit of public service, they said at the end and so forth. They had all the definitions of professionalism said that we're going to do public service. And the question is, what might that mean? Now, in the IEEE Code of Ethics, it says, in accepting a professional obligation to our profession, its members, and the communities we serve, it says, to improve the understanding of technology, its appropriate application and potential consequences. Well, improving the understanding of technology, that might be relevant to communities, but it's not real relevant. Let's look at NSPE, what it says down further in the canons. Engineers shall seek opportunities to participate in civic affairs, career guidance for use, work for the advancement of safety, health, and well-being of their community. So that is the code for a professional engineer. All right, has that statement. Now, civil engineers have a statement. Engineers should seek opportunities to be of constructive service in civic affairs and work for the advancement of safety, health, and well-being of their communities. Now, in another joint IEEE Association for Computing Machinery, ACM, task force put out a statement that says the public, software engineers shall, as appropriate, be encouraged to volunteer professional skills to good causes and contribute to public education concerning the discipline. Now let's switch professions. Let's do some comparative professionalism. The American Medical Association, June 2001, on Principles of Medical Ethics, has a statement that says a physician shall recognize a responsibility to participate in activities contributing to the improvement of the community and betterment of public health. And later on, they say a physician shall recognize a responsibility to participate in activities contributing to the improvement of community and betterment of public health. Okay? Now, what doctors do often is they have free public clinics. Okay? And then they also have this organization worldwide called Doctors Without Borders, where the doctors go and volunteer in a lot of either war-torn areas or in the developing world to try to help. They do operations and help with the health of people. It's interesting, though, that the American Bar Association, or ABA, model rules of professional conduct say voluntary pro bono publico, that means free service. Every lawyer has a professional responsibility to provide legal services to those unable to pay. Wow. I mean, that's a very clear statement. But they qualify just a little bit. They say a lawyer should aspire to render at least 50 hours of pro bono publico services per year. Now, that's in the legal tradition of this country, because people that aren't able to pay, they either get a public defender or they get somebody that will volunteer for them pro bono, right? And it's considered, when you go into the professional law, that you'll do that. Question: what is an equivalent thing for engineers? Okay. IEEE took it out of their code of ethics. In their 1979 code of ethics, it says, contribute professional advice as appropriate to civic, charitable, or other nonprofit organizations. Seek to extend public knowledge and appreciation of the profession and its achievements. So yank those two, okay? And it's shortening to get down to their 10 statements. So they destroyed a key aspect of the spirit of professionalism with their 1990 revision or shortening of the 1979 code, which I think personally is unfortunate. Now, social justice perspectives on this. If you take the statement, hold paramount to safety, health, and welfare of the public, then maybe we should add this statement and encourage engineers to focus on improving the worst safety and health and welfare problems. Is that a better statement? I mean, should we as a profession, because this doesn't say you have to do it as an engineer. You can go work for Google and focus on the richest people in the world or whatever you want to do. Okay, that's fine. This statement says that the overall profession should be doing serving all the public, but in particular helping those that are worse off. And this kind of a statement, adding this kind of statement, is a little bit controversial. I understand that. But many people's social justice perspectives, whether those perspectives come from religion or whether they come from a secular, atheist, agnostic viewpoint, would support this statement this way. Okay? So, for instance, the Catholics have their way of saying it, as do the Jewish and Muslim perspectives. From the secular perspective, there's John Rawls and Amartya Sen that have statements along these lines. In fact, what's interesting is all these traditions, if you will, from a Christian perspective to a Jewish and Muslim and then secular perspectives, would actually, if you read them carefully, they would support that top statement. Okay, and so it's rather surprising. I mean, that statement at the top, it seems to have grown out of a long tradition in engineering, and in a tradition in engineering that tried to be broadly inclusive. But in a certain sense, I think it failed because it's not inclusive of many perspectives. That's a pretty wide variety of perspectives right there. That's not all the perspectives. I didn't write down a Hindu perspective, a Buddhist perspective, a Confucius perspective, okay? It's very complicated to make something truly inclusive around the world, without a question. But already, just in studying 1, 2, 3, 4, 5 perspectives, which represent, well, billions of people in the world, they would support the top perspective. Okay? So, does an engineer have an obligation to serve humanity? Well, in a sense, I mean, can you name anything we do as engineers doesn't serve humanity? We create all these technologies. What do you think they're for? They're typically to reduce toil, to automate things, make things easier, right? Make life better. Okay? The question about serving humanity is what piece of humanity you try to serve. Okay? And another question is do you do it for free? That's a rather complicated issue. We'll come back to that later in class. Does an engineer have an obligation, even with paid employment, to help the worst cases for capability deprivation? And then the question you'd have is are those obligations we might have, are they duties? So in other words, some people would say that the American Bar Association, the American Medical Association starts to sound like it's your duty to do that. Well, then the question, if it's a duty, then the question is can you bring the force of law behind that duty and force you to do something? I don't think anybody's talking about something like that. Coercion is not something people are talking about. Coercion to do volunteer work certainly is not reasonable. Okay? Coercion to fulfill the duties of protecting the safety, health, and welfare of the public is going to come in one sense for you people, whether you like it or not, and that is that if you hurt the public and welfare, you're going to end up against the law, right? I mean, you're going to do something against the law, and you can be prosecuted for that as an engineer if you end up hurting people or destroying the environment. Okay. So, we're at the end. Attendance question. So you're gonna write this on a sheet of paper, and your hand is to Veronica. Where's Veronica? There's Veronica over there. Veronica's gonna come over here to the door over here. This attendance question is this phrase came from the IEEE Code of Ethics that we just read. It says to improve the understanding of technology, its appropriate application, and potential consequences. So write down as many strategies as you can for satisfying this statement. Now you'll notice it doesn't say who the audience is. Okay? You can pick the audience you're talking about. Right? The audience can be a wide range of different cases, actually. Okay. And then turn in the sheet, to Veronica.